Today we're going to be looking at our growth and decay word problems. We're going to be doing similar to what we were doing yesterday, but we're going to be having to take and translate word problems into a nice neat formula to figure out what's happening. Our general formula for our exponential growth is this. That's what we're going to be doing. What's right here. It says y is equal to a, parentheses, 1 plus or minus r to the power of t. Y is going to be our final value. Final value. This is what we're going to be looking for. What is this? A is our initial value. What did we start with? That's what we're going to be doing here for our A. What did we start with? Our initial value. Our plus sign, in this case, if it's going to be 1 plus r, that means plus. This means this is going to be an exponential growth. This is a growth function. And since this one is a growth function, that means that this one must be a decay function. R is our rate. That is a percentage. So we put our percentage. We can divide it by 100 and change it into a decimal, or you can just change your percentage to a decimal. And then T stands for time. And we'll try and keep that out of the bottle. The next one we have here, so we're going to actually go through and work a few of these things out. So looking at this, it says the population of Johnson City has grown at a rate of 3.2% per year since 1989. If the population in 1989 was 25,000 people, what was the population in the year 2000? So first we're going to look at this right here. It says grown. This says grown. This is a growth problem. So that means I'm going to be using the formula y equals a times 1 plus r to the power of t. So go and collect my information. I need a, I need r, and I need t. A is what we start with. We are starting with 25,000 people. R is our percentage. It's 3.2, so I'm going to put 3.2 over 100, which gives me 0.032. T is our time. Alright, so at time, I'm going to go through and say, hey, I'm going to take 2,000 and I'm going to subtract 1989, and I find out, hey, t is going to be 11. So that is 11. So now I'm going to plug this into my handy dandy formula here. So y equals 25,000 parentheses 1 plus 0.032 to the power of 11. So we now go and get our nice handy dandy calculator here. We go in and we first turn the calculator on. There we go. Well, I don't need that information. Let's get that out of there. So I'm going to put in here 25,000 parentheses 1 plus 0.032, close your parentheses, caret does our exponents, to the power of 11, and then I hit enter. And this gives me a value of, says y equals 35352.219. Now remember, we're talking about population and people, so we cannot have 0.219 of a person. So we round that up, so we would say our population would be 35,353 in the year 2000. Here our example 2 tells us a tractor has a depreciation rate of 19% per year. If the original price of the tractor was $29,000, what is the value of the tractor 5 years later? So we're talking about depreciation here. Depreciation means this is going to be a decay problem. So that's going to be y equals a times 1 minus r to the power of t. I'll go find my a, my r, and my t. T they flat out gave us. It's right here. 5 years. R, they told us it is 19%, so I'm going to put 19 over 100, which gives me 0.19. And our A is right here, $29,000. I go and substitute these in, so Y equals $29,000 times 1 minus 0.19 to the power of 5. I go and collect my handy-dandy calculator to help me out here. So here I'm going to do 29,000, parentheses, 1 minus this time, because it's a decay problem, 0.19, close my parentheses. My exponent this time is 5. Press enter, and we see that we have y is equal to 10111.67476. Here we're talking about money. When we're talking about money, we have to only go 2 decimal places. And we don't round this one up. We would round it using our regular rounding rules. So we would know that our value for our tractor would be $10,111.67 after 5 years. All right, now we're looking at example number 3. Number 3, we're going to be looking at investing. Suppose you invest $1,000. So if I'm investing my $1,000 in an account paying 5.5% interest compounded annually, which is a really good deal in today's market, it says find the balance after 3 years. All right, so if I am investing, it says right here investing, this is going to be a growth problem because we're hoping our money grows. That would be a good thing. So my equation would be y equals a times 1 plus r to the power of t. So I would need to find my a, my r, and my t. A in this case is $1,000. I put $1,000 into an investment. My rate is 5.5 over 100, which is 0.055. My time, they told me it's 3 years. 3 years. So I'm going to 3 right here. So I'm now going to have y equals 1,000 times 1 plus 0.055 to the power of 3. So now we get our handy-dandy calculator to help us out. Figure out how much money do we have in the bank now. Well, I go up and turn on calculator. Hey, there we go. So I type in 1,000. 1, 2, 3, parentheses, 1 plus 0.055, exponent of 3, and I hit enter, and it says y equals 1174.241375. And again, we are dealing with money. Since I am dealing with money, I only need 2 decimal places. So my investment now is worth $1,174.24. And we are done. Hope you enjoy doing our growth and decay problems. And this video was filmed before a live studio audience.